In this video, I'm going to go over two questions from your note package. So we'll look at this question and then a corresponding diploma question. And then I'm going to do two additional questions from a worksheet that I've uploaded to the Google Classroom. Before I start this question, I want to look at the original equation of a rational function before any transformations. So the original equation of a rational function is y is equal to 1 over x. This is the corresponding graph. So with the graph of y is equal to 1 over x, we know that x cannot be equal to 0. That's going to be our non-permissible value. That's going to give us a vertical asymptote at x is equal to 0. So here's my vertical asymptote. Then if I look at the degree of the numerator is less than the degree of the denominator. So there's a horizontal asymptote at y is equal to 0. So this is the original graph before any transformations. Then we're going to have transformations and we're going to come up with the new equation. They want the equation of this graph written in this form here. So this should look familiar from transformations. So we have a k value, which is going to move our graph up or down, and then we have an h value, which is going to horizontally translate it left or right. But what's going to happen with rational functions is this k value is going to correspond to the horizontal asymptote, and this h value is going to correspond to the vertical asymptote. So if I look at the horizontal asymptote of this graph, it is at y is equal to 4. So the original equation of the HA was at y is equal to 0. This was vertically translated 4 units up. That's a k value. K is going to be equal to 4. So this will be 4. Essentially, it's a replacement on y, and y is replaced with y minus 4. So if I write the equation with my k value in, it's going to be a over x minus h plus 4. Then if we look at our vertical asymptote, so the vertical asymptote of this graph is at x is equal to 2. The original is at x is equal to 0. So it was horizontally translated 2 units to the right. That is going to make my vertical asymptote at x equals 2. So this, we're going to have an h value of 2. It's going to be an x replacement, and x will be replaced with x minus 2. So we will get y is equal to a over x minus 2 plus 4. Okay, so here our graph is going horizontally 2 to the right, and it's going to go vertically 4 units up. Now we need to calculate the a value, and to calculate the a value, we're going to use a given point on our graph. So they actually gave us a few points to choose from. I'll use this point, so 4, 8. I'll substitute it in and calculate a. So 8 is equal to a over 4 minus 2 plus 4. I'll subtract 4 from both sides, and I'll get 4 is equal to a over 2. Multiply both sides by 2, and I will get a is equal to 8. If I input that into the equation, my new equation is going to be 8 over x minus 2 plus 4. What I always recommend is plugging this into y1 on your calculator and making sure that your graph matches. You're going to need some brackets, so here's how I entered it. I wanted this to be in a bracket, so I did open bracket 8 divided by, and then I put this binomial in a bracket, plus 4. This is the graph, and I just want to verify that points match. So if I look at the table of values, I want to check 4, 8, 6, 6. So our graph is matching. Okay, let's look at a diploma question that would relate to this. So they give us this function, and they're asking us where the vertical asymptote is located and the horizontal asymptote. So again, recognize that this is in this form. Our graph is going 3 units up. So remember, the original function is 1 over x. that function is going to be vertically translated 3 units up, which is going to give us our horizontal asymptote. So there's going to be a horizontal asymptote at y is equal, I think I said vertically, but yes, it's going to vertically go up 3 units, which will give us the equation of our horizontal asymptote at y is equal to 3. This is going to give us our h parameter, so h is going to be -1. That's going to move our graph 1 unit left. That's going to give us the equation of our vertical asymptote. So we'll have a vertical asymptote at x is equal to -1. So the answer, vertical asymptote is located at 2 and horizontal asymptote is located at 8. Let's look at this first question from the worksheet. So we have a different form of the equation. So we don't have that, we can't clearly see the x replacement and the y replacement. But we've done a lot in this form. So let's work with this equation and see what we can get to get our graph. So we always want to factor g of x is equal to 4 for x plus 1 for x plus 2. There is no common factor, so we know that there's going to be no hole in the graph and that this is going to be a vertical asymptote. So there's going to be a VA at x is equal to -2. So let's put our VA in. Okay, now I'm going to look for my horizontal asymptote. So let's look at the degree of the numerator, degree of the denominator. So the degree of the numerator is 1, degree of the denominator is 1. So there's going to be a horizontal asymptote at y is equal to a over b. A is the lead coefficient of the numerator, b is the lead coefficient of the denominator, which will give us a horizontal asymptote at y is equal to 4. Okay, the remaining factor in the numerator, remember, gives us our x-intercept. So the x-intercept of this graph is going to be at -1. Let's calculate the y-intercept of the graph. So we're going to let x equal 0. And we'll calculate g of 0. G of 0 is going to be 4 over 2, which is 2. So the y-intercept is at 2. Okay, so let's finish our graph. So this is what our function would look like after it undergoes those transformations, various transformations. What it says here is now it says g of x, so the original g of x can also be expressed in this form. And we know that this form, that is going to be our k value, our horizontal asymptote at 4. That's going to be our vertical asymptote. So what this first part says is algebraically prove that the two forms are equivalent. So how I'm going to algebraically prove that is I'm going to combine, I'm going to make two fractions. So g of x is equal to -4 over x plus 2 plus 4. Okay, I want to get common denominators. I'm going to get a denominator of x plus 2. That will give me g of x is equal to x plus 2 is my denominator. My numerator is -4 plus 4x plus 8. The numerator can be simplified to 4x plus 4 all over x plus 2. So I just proved algebraically that this form of the equation is equal to the original form that we were given. They're equivalent. Now what I'm going to do is I'm going to show you the transformations using replacement notation that would have occurred to the original function in order to get this. Okay? Okay, so remember that we always want to do SRT. So we want to do our stretches, reflections, and then translations. So if I match it up to this here, actually I'm going to write that. They want me to use this form. So we're going to use the form y is equal to negative 4 over x plus 2 plus 4. Okay, I'm going to start with the a value, which is negative 4. That's going to tell me two things. There was a vertical stretch and there was a reflection that occurred. So we're going to do the stretch first. Stretches, remember, are a y replacement. So what I want to get in front of this function is a 4. So the y replacement would be y is replaced with 1/4 y. So the original equation is y is equal to 1 over x. This will come out and it's going to be replaced with 1 over 4 y. Okay, let's isolate y. I'm going to multiply both sides by 4. And I will get y is equal to 4 over x. Now I'm going to take care of the reflection. So this is a reflection and there's a negative here, so we know that there's a reflection. That's going to be a replacement on y, so y is replaced with negative y. So again, this is where we're at. So y is equal to 4 over x. And then I'm going to replace y with negative y. Divide both sides by your negative 1. And you will have y is equal to negative 4 over x. So hopefully you see that there's a reflection, because remember, this is the original graph and this piece has been horizontally reflected over here. Now we'll look at our two transformations. So our two transformations, we know that there's going to be an x replacement. So x, where's my original? X is going to be replaced with x plus 2. So we have y is equal to negative 4 over x, and then I'll do the replacement. Y is equal to negative 4 over x plus 2. So that's going to move our graph 2 units to the left. And then we have our k value, which is 4, so it's going 4 up. That's a y replacement. So that's going to be y is replaced with y minus 4. So this is what we have so far. And we'll do a y replacement. And then I will add 4 to both sides. And that's how, using replacement notation, we would get our equation in this form. Okay, let's do this last question. The graph of a rational function shown contains this point. Determine the equation of the function in this form. Okay, so let's locate our vertical asymptotes. So we have a VA here at x is equal to 2. I know that my denominator is going to have a factor of x minus 2. Then I have a VA at x is equal to negative 4. So I know the factor in my denominator for that will be x plus 4. There's no holes in this graph, so there's no common factors. We have an x-intercept. So that's going to be the remaining factor in my numerator, and x is equal to 0. So there's my x-intercept. And then we're going to have to calculate our a value. In order to get the a value of the graph, we need a point. So this is the point that they want us to use. Negative 1 is equal to negative 8a. Negative 8 minus 2 will be negative 10. Negative 8 plus 4 will be negative 4. That will give me negative 1. Multiply both sides by 40, and we will get negative 40 is equal to negative 8a. Divide both sides by negative 8, and we will get a is equal to 5. So I know my a value is 5. They want me to write it in this form, though, so I'm going to expand those two binomials. So y is equal to 5x, and then I'll have x squared plus 4x minus 2x, so plus 2x minus 8. Again, enter that into your calculator. Put this trinomial in a bracket when you do, and make sure that everything is matching. So make sure that point matches, your x-intercept matches.